Welcome to an example for the design for Flexure and Shear, or the mechanics of deformable body. Let's proceed to itong sample problem number 4. So we have a rectangular beam, 6 inches wide by 10 inches high. Supports a total distributed load of W, again, omega or W na po na itong load diri, and a concentrated load of 2W, applied as shown in figure 583. If ato ang bending, minimum bend, the maximum flexural stress nga pwede lang is 1,500 pounds per square inch. Atong maximum shearing stress is just 120 psi. Determine the omega or W. So, tama ni nato. So, for this one, okay. So, atong this one, kani siya nga W, this is like a, kung ano siya, mura ni siya resultant nga force for this distributed load. Ato pa, this is W over 12 ang iyang distributed because of this one. 12 foot man siya. And then we have also the 2W here. So if we same upon first is you get the reaction. So mag-sum of moment ko at reaction 2 equal to 0. And then clockwise rotation is positive. Okay, let's say this one is reaction 1. And the right side, this is reaction 2. So reaction 1 times 12 feet minus we have the W kaning reaction, the resultant force due to the distributed load, and then times 6 feet yung moment arm, also minus 2W kaning concentrated load diri, times 3 feet is equal to 0. So 12R1 is equal to natay 12W. Therefore, ato ang reaction 1 is equal to W. So, summation of forces Y is equal to 0. So, after nimo mag-sum of moment, mag-summation of force Y man ka, so we have R1 plus R2 is equal to, so natay W plus 2W. So, R1 nato is equal to W plus R2 is equal to 3W. So, nato pa si R2 is equal to 2W. That's 1. Okay, next na ito buhaton. So we draw the shear and moment diagram. Ako lang isulat diri no, so from our previous problem, we have this result. Atong reaction 1 is W and reaction 2 is 2W. So this is reaction 1 is W and our reaction 2 is 2W. So okay, magbuhat ko W. We have also 2W there. And then we have a uniformly distributed load. This is W over 12. And then napot tayo 2W3. Okay. So shear and moment diagram. Atong buhaton. We have a shear diagram and also a moment diagram. Always ginusuno nga mahitabo. Get the reaction, draw the shear and the moment diagram. So natay pasaka nga W and then unaog din si W. Kay panawag man ang na may panawag nga force nga W over 12. Pag abot dire, so napag-view mo na nga 2W. Downward. Tapos, kung ato siyang i-drawing, napod na siya munawag dire, and then, musakat ta dire. Karon pila man ni siya. So, ato lang na i-multiply, no? W over 12 times, this distance is 9 feet. Diba? So, times 9. this is equal to 3 over 4 W. So W minus 3 over 4 W, this is W over 4. And then inaog pag yung W, so that becomes minus 2W pag yun. So here we have negative 7 over 4 W plus ninaog pag yung diri. Kani because of this load, so this becomes a 2W and then isaka din siya. So for our moment diagram, so we can simply assume nga ani ang itsura and then inaog siya. Now, to maximum moment is kung asa man nag-zero ang shear. So sure na gyud nga na itong maximum moment diri. Now to alang maximum moment is we can get just the area of this one, positive area, and then we can obtain the maximum moment. So atong kuan, maximum moment M is just equal to, so this is a trapezoid, di ba? We have 1/2 base 1 plus base 2 over this distance, na 9 feet times 9 feet. Ato ang moment, maximum moment is 1/2 times base 1 plus base 2 times, that is 5.625, yes, 5.625, and then this is pound foot. Pound foot. So this is our maximum moment. So from there, we can start now our calculation. So kanidrea, we have the shear and moment diagram. So alam mo kalibog on the right side, you notice, now we have this one. So kaning 45 W over 8, this is just equal to 5.625 W. Okay. Applying the values we have ato ang maximum shear, pila to, that is 2W, so maximum shear in pounds, and then ato ang maximum nga moment is 45 over 8 W pound foot. Okay, so let's start with the flexural stress. So natay dimension ni beam, no, rectangular beam that is 6 inches by 10 inches. So atong flexural stress, we have 6M over BD squared. So ito lang substitute ang values. The FB na to is 1,500 pounds per square inch. Equal to 6 times atong moment is 45 over 8 W. This is pound foot over BD squared. So we have B nga 6 inches and then ang D is 10 inches squared. So ang pounds diri sa left side, makancel ang pounds diri sa right side. And then kani siya si 10, may mo ning inch squared, so makancel po ni siya diri. And then kani si inch diri, ato na himuon og feet, so we have 12 inch per foot. Makancel si inch, makancel si feet. So ang mabili na lang nga unit is para kang W. So, remaining values, we have 1,500 is equal to 6 times 45 over 8 W times 12 over 6 times 10. Cancel 6. So, ang W is equal to 2,222.22 pounds. So about next one is for our shear. So ato ang maximum shear for a rectangular section, again, that is 3V over 2P and T. So ato lang substitute, we have atong allowable or maximum allowable shear is 120 pounds per square inch is equal to 3 halves times atong V or shear is 2W. And then this is in pounds. Over BD. So atong base is, you have 6 inches times 10 inches. Kani inch diri, makancel ni square inch diri. Ang pounds diri, makancel ang pounds on the right side. Ang 2, makancel ang 2. So para madali atong life, ato lang ni mo 120 is equal to 3W over 6 times 10. From here, we can solve that our W is equal to 2,400 pounds. So this is according to here. So pila man na to ang W dapat nga gamiton? Is it the 2,222 or 2,400? So yan ni siya. Ano si 2,000? Once nga ang load sa beam is maabot og 2,222, maximum na 4 ato ang bending stress. Ang 2,400 is maximum na pod for shearing stress. So kung 2,400 na nga to ang load, pasabot, nag-fail na si bending. Kaya ang kaya lang nga load is 2,222.22 pounds. So therefore, ato ang final answer should be this one. W is equal to 2,222.22 pounds.